everyone, welcome back to another episode of Coding Bytes. I am Thinzar, an educator here at Coding Lab. If you've programmed using Scratch before, you might already know how to let your user control sprite movement on the stage. But what about making a map that's bigger than the stage? You might have already seen such a feature in games such as Minecraft, Subway Surfer, Pokemon Go, and more. Today we'll be learning how to make a scrolling adventure, where it seems like our character is able to navigate a very large area. First, let's see what a scrolling adventure game looks like. When the game starts, do you see that Taylor is at the center of the screen? There's Tatiana, a character we can talk to. Let's walk to her and click on her to talk. We'll use the arrow keys to move. Alright, we should be finding 3 fruits. Let's walk around and find them. Alright, we've got all the fruits. Although it seems that Taylor is walking around, did you notice that he's always at the same place on the screen? While it looks like he's moving around, and Tatiana and the fruit seems to be at fixed places on the map, Taylor is actually not moving. Everything else is moving to create the illusion of Taylor's movement. Now let's go back to Tatiana. Notice how Tatiana stayed in the same place? Okay, with that, we have completed the quest. This is how the game looks. Now, let's make this program. Log into your Scratch account and click on the link in the description box below for the project template. Remix the project and let's get started. First, let's take a look at the sprites. You may notice that we have some sprites named placeholder. These are empty sprites with no code inside. We only use them to help us with the map arrangement in the game. Now, let's click on Taylor. We're going to use the arrow keys to move Taylor. But first, we need to remember that although Taylor looks like he is moving, the background is the one that moves. To do that, we're going to create 2 new variables. Let's go to Variables and click on Make a Variable. To ensure the game starts from the middle, we will set X scroll and Y scroll to 0 when the green flag is clicked. If we want to create the illusion of Taylor moving up, everything else has to move down since the background is moving. What we know about coordinates is that to move down, the Y coordinate value should decrease, so we'll decrease the value of the Y scroll variable. The same logic applies for the opposite direction, as well as for X scroll. Since we will be reusing similar code, let's make a block to move Taylor. Let's go to My Blocks and make a block. We will name this block Move, and we'll need to add 3 inputs. The first input will be the direction. Second is going to be X change, which will tell us the direction X will be changing in. And the last is Y change, which does the same thing, but for Y. Now, let's define the block. First, we're going to make Taylor look in the direction that he is walking. So let's use the point in direction block, together with this direction block, which represents the direction that Taylor will face. Then, we're going to change X scroll by negative of the change in Taylor's X coordinate X change. And we also want Taylor to move by 10 pixels. We'll grab 2 multiplication blocks in operators and combine them. Then, we'll say -1 times X change times 10. With that, Taylor will look and move 10 pixels in the correct direction each time this code is run. The Y coordinate will follow the same method, so we'll duplicate this, change X scroll to Y scroll, and put in Y change instead of X change. Lastly, to animate him and make him look like he is moving, let's go to Looks and take out the next costume block. Now, let's move Taylor using the arrow keys. Let's start with moving upwards using the up arrow. We'll use the key pressed even block. Then we want Taylor to face up, so Taylor will need to point in direction 0. Let's drag out the move block for my blocks and put 0 for the first input direction. Then we want Taylor to move up, meaning y change should be positive and x change should be 0. Let's put 0 for x change input and 1 for y change input. We will follow the same steps with different values for the other directions. Here's what the final code should look like, and we're done. Now we have our variables, but we're not done yet. We need to make sure our map moves according to our scroll variables, so we'll be coding our map sprites. They are named based on their locations at the center and the directions from the center. You can take a look at the image on the screen for the various directions. Please pause the video if needed. Let's work on the O sprite first. We're going to make the maps move according to Y scroll and X scroll variables. For the origin map, O, it's simple. We're going to make sure this map's coordinates are exactly Y scroll and X scroll forever when the green flag is clicked. Let's use the go-to motion block and the variable blocks for that. Now that this block is done, let's try moving. This is nearly perfect, but if we try moving upwards, do you see that origin map is stuck here at the bottom? That is because the X and Y coordinates are beyond the height and width of the O sprite. To fix this, we're going to hide the sprite once it's not able to go back to where it should go. Basically, when it is at the far edge of the screen. We'll only show it if the X scroll and Y scroll are within a valid range of numbers. To program this, we'll need the if-then-else block in control, along with Y position and X position blocks in motion. Now, we're only going to show if they are equal to the X scroll and Y scroll variables. Let's get the operator blocks, drop the position blocks, and then the variable blocks. To check for both conditions, we will combine the blocks using the AND block. Lastly, let's add in the hide and show blocks from looks. Now, let's test out the O sprite. The sprite disappears once we go beyond it, and appears again once we get back to the original area. Great! Since we are done with the O sprite, we will apply the same method to the rest of the map. Take a look at the image on the screen for a better idea of the X and Y coordinates of the various map sprites for the map. Please pause the video if needed. Let's modify our code in the O sprite so we write out the formula for all map sprites. We'll take out the X scroll and Y scroll variable blocks from our current code. We will modify it with the addition and multiplication operator blocks. Since the origin sprite is the center of the map, it is meant to appear as long as the X scroll and Y scroll are within the stages width and height. This means it is 0 pixels away from the X scroll and Y scroll. So it will be X scroll plus 0 times the stage width and Y scroll plus 0 times the stage height. Let's place the blocks accordingly. Our blocks should look like this once we are done. Now that we have modified this set of blocks, we will save it in the backpack so that we can use the same block but change the numbers for the other map sprites. Go to a map sprite and drag out the block from the backpack. Make sure to do the same for all map sprites. We should all have copied the blocks into all 9 map sprites with the help of the backpack. Now, let's change the numbers. We'll start from the west, the W sprite, and go clockwise. For the W sprite, it is 1 stage width away to the left. So it should be X scroll plus minus 1 times 480, the stage width. Y scroll will not be affected. Make sure to change the numbers in both the go to block and the if conditions. Then, for northwest, the NW sprite, it is 1 stage width away to the left and 1 stage height above the origin, the O sprite. That means it is X scroll plus minus 1 times 480, the stage width, and Y scroll plus 1 times 360, the stage height. Then for north N, it is y squared plus 1 times 360. Northeast and E is 1 for both x and y. East would be 1 for x. Southeast would be 1 for x but minus 1 for y. South would be 0 for x but minus 1 for y. Lastly, southwest would be minus 1 for both x and y. With that, we are done. Let's test it out. Let's go up and down, then right, then left. Great, the map works perfectly now. We are left with one last part of the scrolling adventure, our other sprites, specifically the items and characters that our main character Taylor will interact with. In the game, we put Tatiana in the origin map, so let's go to the backpack and drag out the same set of blocks we used for our map sprites. Now, we don't want her to be in the center, but maybe at the top right of it, 100 pixels higher and to the right from the center. To do so, we will use the addition operators block to add 100 to all four sets of blocks used for the x and y. When we press the green flag, we now see Tatiana at the top right of the origin map. Now, adapting the set of code, we can just change the number 100 to modify the locations of the other sprites using our knowledge of x and y coordinates. Let's drop this set of blocks in our backpack so that we do not need to bother with the addition blocks again. We will do something similar for the fruits, but the fruits have some blocks already, as they also take into account the status of the quest. There is no need to worry about the existing blocks. Let's start with bananas. If we want the bananas to be at the top right of the northern map, it means it is one stage height above the origin and maybe 50 pixels from the center of the northern map. We'll take out the set of blocks from the backpack, change the value for times 360 to 1 in both goto and if, and add 50 to both x and y. After this, we will move the blocks in the forever block to this set of blocks here. This is because we only want the bananas to appear after talking to Tatiana about the quest. Here is what the code for bananas would look like. We will do the same for the apple and the orange. For the orange, we'll put it at the top right of the southwest map. Let's take out the blocks from the backpack and do minus 1 times 480 and minus 1 times 360. Here is what the codes will look like for the orange. Then, for the apple, we'll put it at the top right of the northeast map. Taking out the blocks from the backpack, we will do 1 times 480 and 1 times 360. And instead of plus 100, I will do plus 10 for both, so that it is not so far from the center of the northeast map. This is what the code for the apple looks like. At first, we will not see the fruits yet, as they are programmed to appear only after we talk to Tatiana. So let's talk to her first, then walk around to collect the fruits. Alright, now when we walk around, we should be able to see the fruits and Taylor can touch them to collect them. Okay, now that we've collected all the fruits, let's get back to Tatiana. Great, we have completed the quest for Tatiana, and that is the end of our scrolling adventure. Of course, that's not the end yet. We can further upgrade our program by making sure that our maps are much nicer looking instead of just plain color. We can also add more characters for Taylor to interact with, and even make it such that Taylor cannot move outside of the map sprites. Do continue upgrading your scrolling adventure and show us your improved versions in the comments below. We would love to see your creations. That's all for this episode. If you enjoyed this video, do remember to give us a like by clicking the thumbs up button below, and remember to subscribe for more Coding Bytes. Thank you for watching, and see you again soon.